So we're still trying to find all the zeros of a polynomial function. But sometimes when our a sub n value is not 1, in this case it's 2, that doubles the number of possible solutions we could have using the rational root theorem. And also when we have an a sub 0 that's 42, that also gives us a lot of coefficients. So one way that can help us really focus in on what our zeros are is we can use a graph. And from the graph, we can see that for this function, 2x to the fourth plus 5x cubed minus 18x squared minus 19x plus 42, we can see that, yes, there's a 0 here, but negative 3.828 is not exact. Then we have a 0 where we know that it's at negative 2 is a 0, 1.5 is a 0, and then we have another 0 that is not exact. So we can use these two to help factor our polynomial down, where we can use some of our other tricks. So here we have our polynomial, and we're going to use synthetic substitution. And from our graph, we know that negative 2 is a factor and 1.5 is a factor. So our coefficients are in descending order, 4, 3, 2, 1, 0. And so we can write those down, 2, 5, negative 18, negative 19, and 42. And the first one that we're going to find out, now when we factor out and find out what a 0 is, we're going to have some polynomial left. And so we know that negative 2 is a factor, but we got to figure out what will be left when we get done. So we're going to add down and multiply in the diagonal. And we add down, we get 2. Multiply in the diagonal, we get negative 4. Add down, we get 1. Multiply in the diagonal, we get negative 2. Add down, we get negative 20. Multiply on the diagonal, we get 40. Add down, we get 21. Multiply in the diagonal, we get negative 42. And just as we expect, 42 minus 42 is 0. And so now from what we remember, this is the remainder. Remainder 0 means that is a factor. Then we have a constant. We have our linear term. We have our quadratic term. And we have our cubic term. So now we have to factor this polynomial here. And so we have to use the coefficients that we have right here, which are 2, 1, negative 20, and 21. And we know that 1.5 is also a factor. So we're going to put 1.5, and we're going to do synthetic substitution again. So add down, multiply in the diagonal, and we get 2. 1.5 times 2 is 3. Add down, we get 4. Multiply by 1.5, and we get 6. Add down, and we get negative 14. Multiply in the diagonal, and we get negative 21. And 21 minus 21 is 0. And so our remainder, then we have our constant, our linear, and our quadratic. And now based off of the numbers that we looked at previously, I know that this is not going to be a factorable polynomial. And so what I'm going to do is I'm going to write it down. We'll write it down over here. X plus 2 is a factor. That gives us a 0 of negative 2. X minus 1.5 is a factor. That gives us that 0. And then we have our quadratic left. So 2x squared plus 4x minus 14. And that is not going to be easily factorable for us. So what I'm going to use is I'm going to use the quadratic formula to figure out what the zeros are. And so the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over, and that's the square root, all over 2a. And from our quadratic part over here, we know that a is equal to 2, b is equal to 4, and c is equal to negative 14. So I'm going to substitute those values into the equation. So we get x equals negative 4 plus or minus the square root, and then we have 4 squared minus 4 times 2 times negative 14. All that is going to be divided by 2 times 2. And so we can rewrite that as negative 4 plus or minus 16 plus 112, all under the square root, and that's divided by 4. And then we can solve that further, or simplify that further, and we get x squared is equal to negative 4 plus or minus 128, all under the radical, all divided by 4. And we can simplify our radical of 128, square root of 128. We know that it's even, so it's divisible by 2, so we can do the square root of 2 times 64. And we know the square root of 64 is 8, so we can rewrite this as 8 times the square root of 2. And that is what we wrote. That's how we can rewrite the square root of 128. So we're up here, and we get negative 4 plus or minus 8 times the square root of 2, all divided by 4. And we can divide 4 into both terms, both the negative 4 and the 8 square root of 2. And then we're left with negative 1 plus or minus 2 square root of 2. So that gives us two different answers because it's plus or minus. So that gives us two different x's. That gives us negative 1 minus 2 square root of 2 and negative 1 plus 2 square root of 2. So our four solutions for this one, we have negative square root of 2, or excuse me, negative 1 minus the square root of 2. We have negative 1 plus 2 square root of 2. And then we have the one we started out with, negative 2 and 1.5. Those are the solutions for our graph. And if we look at our graph again, this one would be our negative 1 minus 2 square root of 2. And this one over here would be our negative 1 plus 2 square root of 2.